Here is the program that implements the DUT. In the design code, first the structure named bus_packet_t is defined to model the data packet which you have already seen. Next, another parameter is derived from this structure as shown here. It represents the width of the bus in each interface, and named as bus_width, which you can use in the design and test bench code. The $bits is a $function or inbuilt function available in Systemverilog which will return the width of the parameter passed. It is a convenient way to get the width of a structure, and the advantage is, if the specification added one more field in the packet later, bus width will be automatically taken care everywhere in the code. In this example, this parameter is not used inside the design, but a typical design use case of this will be to specify the width of FIFO in the RTL which will store the packet. Next is enumeration definition to specify different address ranges that you have already seen. Also, one more enumeration is defined with name, bus_name_t, to address different interfaces in the ports. Here is the design module with name my_dut. It got an input port named bus_in, which is of type bus packet t, and an output port named bus_out, which is an array of same type bus packet t and width 5. Each of the bus out member can be used as buses to memory, CPU, power, cache and fault units. That is the reason for defining the structure named bus_name_t. In the functional code, an always comb block is used. Based on the ADDR filed in the input packet, the whole bus in is assigned to respective bus out. The code is written as, if busin.addr is inside memaddr_low and memaddr_high, busin is assigned to bus out of mem_bus and so on. As you can see here, using enumeration and structure will make your code more readable and maintainable. If the structure was not used, you need to define the individual signals of each of the 6 buses in the port list of the module, and assign them individually in these places. By adding a structure, you are able to manage the whole packet with a single variable, with the ability to access them individually if needed, as in the case of the struct.addr. Next you will see a simple test bench for this design.